Hey guys, this is Carrie, and this is the answer key video for homework number 15, I guess. So I'm going to skip through the classwork stuff, and we'll jump straight in with the review of probability and statistics. I might talk a little faster than usual, because I only have 9% left, and I don't have my charger, and I want to make sure I get this video done, because I got stuff to do later today that may be prohibited. So in a grade of 110 students, 30 of them are taking computer science, 34 are taking AP calculus, and there are 15 students enrolled in both. Draw a Venn diagram to illustrate the situation. So you have the whole class, the group that's in computer science, the group that's in calc, and there are some students in both. So to place the numbers, there are 15 students in both. Since we know there are 30 students in computer science, we know we should have a total of 30 in this bubble, which means 15 here. To make 15 plus 15 is 30. And in calc, we need a total of 34, so that's going to be 15 and 19 to give us that 34. Now, in total in this middle section, we've got 49 total students, which means that there are, let me use red, there are 110 minus 49, I think 61 students that are in neither calculus nor computer science. So what is the probability that we pick a student in CS and calc? Well, CS and calc, that is going to be, sorry they keep changing. That's going to be this group in the middle. So let me undo that because I want to redraw on the same diagram. So that would be 15 out of 110 students. Probability of picking a student in CS or calc, or refers to anything in the whole the whole region, because it's anything in CS or calc, including the group that's in both. So that would be our 49 total students out of 110. Shoot, I can't erase back because I accidentally continued drawing. Probability of CS given calc, so if we're given calc, that would be 15 of those kids are in CS out of 15 plus 19, 34 total. And if we wanted to do the reverse, which is the probability of picking a student in calc given that they're in CS, we'd look in the CS bubble, and that would be 15 out of 30. Okay. 32% of seniors at ACTVF have a production internship, 65% have AP classes. Oops, I need a bigger box than that. So we have production, and AP is 65%. And then it says the probability of internship or AP is 78%. So or refers to the whole middle section. So that's 78%. Now what we saw with this is that 78% is coming from adding up this section, and this section. And we don't know any of those, unfortunately. So the way that I like to think about it is the first number I like to place usually is the group in the middle. But because we don't know it, we can say there are X students in both. So the X students in both needs to be, sorry, I'm going to be a while actually, so I can't pause the video, unfortunately, sorry. So can you come back later? Thanks. All right, so we've got X students in both. So to set this one up as an equation, if we take the 32% from here, and we add it to the 65% from here, then what you'll see is we're adding this X group twice. So the way that we can account for that in our math is we do the group that are in the production internship, 32%, and that includes the middle. Sorry, I don't want to actually draw on the diagram here, so that's why I keep undoing. 32% from production, plus the 65% that are in AP, but that counts this group twice, so we subtract off one copy of that, and together that gives us 78%. This is 97% minus X equals 78. And when you solve that for X, just skipping all of the math there, you can do it on your own. I think what you get is 19% for X. Now, to fill in the rest of the table, if this is 19%, that means this will be the other 13% to make the 32%. If this is 19%, this will be the other 46% to give us 65% in total. And if this middle part is 78%, then the part that are in neither would be the remaining 22% from 78% subtracted from 100. So for end, it's the group that's in the middle, so the final answer is 19%. This one was a do now problem that we did a while ago, but it's a good one. The probability that Gary and Jane have a child with blue eyes is 0.25. I'm going to write these as percents because I like to work with percents better. So that's 25%. Sorry, if you need something, you can take it, but I'm making a video, so I can't talk. Then the probability that they have a child with blonde hair is 0.5. That's 50%. The probability that they have a child with blue eyes and blonde hair is 12.5%. So I think the way we want to do this one is to draw a Venn diagram. So we've got blue eyes and we've got blonde hair. The probability that it has both is 12.5%. And probability of blue eyes was 25%. So if this is 12.5%, this will also have to be 12.5% to give us a total of 25. And the probability of blonde hair was 50%. So this would have to be the 37.5% remaining, so that together they make 50%. Putting it all together, 12.5 plus 12.5 is 25, plus 37.5 is 52.5%. 100% minus the 52.5% that's in the middle would give us 37.5% here as well, I think. Nope, 47.5% there. All right, so putting everything together, we need to figure out whether these events are dependent, independent, or mutually exclusive. To test if they're independent or dependent, what we can look at is the probability of blue eyes in general was 25%. The probability of blue eyes given blonde hair is 12.5% out of 50%. And if we do that division, we get 25% here. So because the probability of blue eyes and the probability of blue eyes given blonde hair are the same, it means that these events are independent because it didn't depend whether we had blonde hair or not. It was the same percentage either way. These are definitely not mutually exclusive because there's a group of people, 12.5%, that have both traits. So it is just choice 2. For problem number 4, the results of the survey of a student body at Central High School about television viewing preferences are shown below. Are the events student prefers comedy, so probability of comedy, and probability of comedy given that the student is a girl, are these going to be independent or dependent? These should be equal if they're independent. So let's check it out. So probability of comedy would be 105 out of 420, which is 25%. Probability of comedy given that they're a girl, so since it's given that they're a girl, we know that we're looking at this row. That would be 60 out of 240, which is also 25%. So because these are equal, the events are independent. The next one is going to be very similar, so I'll let you do that on your own. Determine how a controlled experiment can be created to examine the effect of adding ingredient X to plant fertilizer. So for a controlled experiment, the researcher will take 2 groups of plants, and they'll form an experimental group and a control group. This group will get fertilizer plus ingredient X, and this group will just get the fertilizer without ingredient X. And then what we'll do is we'll measure, how much the plants grow, and we'll determine whether this group had a statistically significant better growth rate than the control group. And we probably won't include all of that in the written work here, but I'm at 4% now, so I'm cruising on. So we learned that in addition to experimental controlled experiments, there's something called an observational study. Observational studies are good because they allow you to research things that are maybe unethical to force people to do. But because you're only observing the choices that people naturally make, you can't determine what causes what. So observational studies, oops, sorry, this is what they cannot do. Observational study, oh yeah, this is false. So observational studies cannot determine cause and effect relationships. Administration at ACTVF would like to determine whether the 540 students at the school enjoy school lunch. They randomly survey 30 students in each, sorry, this is another typo that I've made before, 30 students, and found that 18 of them did not like the school lunch. So the sample is the group that you actually survey. It's the 18 students, and the population is the whole school, which is 540 students. 18 was wrong, right? It was actually the 30 students that we surveyed. I'm rushing too much. What we found in the survey was that 18 out of 30 didn't like the school lunch. So I would assume that the same proportion out of the 540, and you're gonna bring it back when?
Yes, I'm gonna bring it after advisory ends.
Okay, please do. So the same proportion would like this. So doing the math here, 18 divided by 30 is 60%, and 0.6 times 540 is 324. Which statement about statistical studies is true? A survey of all English classes in a high school would be a good sample to determine the number of hours throughout the spring spent studying. Wow, that's not even English. A survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the spring spend studying. Oh, that does make sense. Since it's about students throughout the spring, kind of all the students of the school, I don't know if English classes would be a good example to study, unless you could guarantee that all the kids in English class were the whole school. A survey of all ninth graders in high school would be a good sample to determine the number of student parking spaces needed at that high school. Well, ninth graders don't drive, so that would be a bad one. A survey of all students in one lunch period in a high school would be a good sample to determine the number of hours adults spend on social media. Don't think that would be a good one either. A survey of all AP Calculus students in a high school would be a good sample to determine the number of students throughout the school who don't like math. Well, since it's just AP Calculus students and we're trying to look at the whole school, I don't think that would be good. So I didn't like any of these. So I guess this is a best case scenario. I'm going to say that based on my experience teaching high school, most students in the school are in English class. So if we surveyed all the English classes, we'd probably get almost all the students of the school. So probably one is actually good. And so I think it should be one only. The lightning round we didn't get to do, so you can skip that one. For problem 10, the lengths of a certain fish species were found to be normally distributed. The mean length is 74 centimeters with a standard deviation of 14 centimeters. So we draw our graph right away. So 78, 92, 106, is that right? I think so, 106. And this one would be plus 14 would be 120. This would be 64. This would be 50. This would be 36. We want to know about the group that falls in the range longer than 92 centimeters. So longer than 92 centimeters would be here. And this is, I can't talk right now, sorry. This is actually an important, you can come in advisory. This is a challenging question to do because it's not one of the nice ranges, so you could use a calculator to do it, but you can do it without a calculator. So we do know that in this range, if we had all of it, that would be 50%. And we also know that in the 1 sigma range, this would be 68%. So looking at these pieces together, well, the 68%, if we half that, this section would be 34%. So it looks to me like the orange section is going to be that whole blue 50% minus 34% here, and that gives us 16%. So I think 16% of the fish will fall in this range. So since the school has 370 fish, we would do 370 times 16%. And using our calculator to do that, 370 times 0.16 is 59.2 fish. or 59 if we round it. For problem number 11 and number 12, you guys are going to be doing these ones on your own. For problem number 12, I can tell you, I believe the final answer is number 1. I was doing that after school the other day. But unfortunately, my battery life is going to die, so I need to convert the video so I can upload it. Hope this was helpful, guys. See you in class for your final exam tomorrow.